linear differential equations. Let's start this topic, linear differential equations. And this is in general, including the first order, second order, until the higher order. Okay. The importance of linear differential equations is that the linear ODE with constant coefficient can be solved analytically. And the characteristic solution, the characteristic solution. So in general, if you have a higher order linear differential equations, it can be solved analytically, and usually the solution will have the term, exponential term, or the power term, or the sine cosine term. So that is the general characteristic solutions look like, and which give significant insights into physical problem. Into physical behavior. So for example, like our motivation case, which it has the constant linear differential equations, and usually the solution look like the exponential term or sine cosine form. It will give you how those spring will damping, or how the how the spring will be damping with a physical insight. And we will talk about the general terminology and notifications about the linear differential equations. For example, what is the general solution look like? What is a particular solution look like? What is the independence between different solutions look like? And what is the unique solutions? Those kind of general terminology and notification. So we will start with the general form of higher order linear differential equations. General characteristic of linear ODE. So this is a higher order to nth order plus Pn minus 1 x yn minus 1 plus Pn minus 2x yn minus 2 prime plus P plus dot 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 plus P1x y prime plus P0x y equals some function Rx. So this is the general characteristics of linear ODEs. And you know that for linear parts, you can have the coefficients either constant or only as function of x. So the coefficient Pix is either constant or as function of x only. And this Rx is called forcing function. Okay. And both of them are continuous function. That is the general characteristic of the linear ODEs. Okay. And then we can also just use this general form to write the most important. We will learn a lot how to solve it analytically for the second order linear ODE. For a second order ODE linear, we can write as y double prime plus pxy prime plus qxy equals rx. So this is the general form for the second order linear ODEs. You can see that coefficient is only constant or as function of x. And you have a forcing function at the end, which is the rx. And the general solutions, as we say, one of the terminology and notification we will talk about is called general solution. So the general solution is y. This is the general solution is as function of x will be equals to yhx plus ypx. And what